today's short video is going to be molar mass, which by definition is the mass of 1 mole of a compound. Now, when we talk about compounds, remember what we're talking about here are atoms that are bonded together to form more complex entities. So an example of a compound would be something like ethyl alcohol, which has the formula CH3CH2OH. So what this tells me is that I've got 2 carbons, 6 hydrogens, and an oxygen all bonded together to form 1 unit. All right, and this is a molecular compound because we have nonmetals bonded to other nonmetals. Now there are 2 ways I could describe the mass of this compound. If I want to talk about it in terms of a single molecule of the compound, I could just use AMU masses. All right? But that's not terribly useful to us because in most applications we want to talk about moles of compounds because those are actual quantities that we can manipulate and work with. So if we're talking about calculating the mass of a compound in terms of moles of molecules, we're going to refer to this mass in terms of grams. We can actually work with grams. So let's go through this as a particular example using ethyl alcohol here. So what I want to do is I want to basically just deconstruct this thing in terms of the number of carbons, hydrogens, and oxygens we actually have in a formula unit of the compound. In other words, in 1 mole of the compound. So what we have here is if we count up all the carbons, it looks like I've got 2 carbons here in the formula, and each carbon, in terms of its mole quantity, has a mass of 12.011 grams of carbon, right? Because we know that 1 mole of carbon has a mass of 12.011 grams of carbon. Okay, so I have 2 carbons per formula unit times the molar mass of carbon. So that gives me a total mass of 24.022 grams of carbon in 1 mole of the compound. We can do the very same thing with hydrogen. If you go back and look, I've got 3 plus 2 plus 1, which is going to be 6 total hydrogens in the formula unit of the compound. I know that each hydrogen has a mass of 1.008 grams per mole of hydrogen times 6 of them in the formula, giving me a total mass of 6.048 grams of hydrogen. All right, finally we have the oxygen. You'll notice in the formula there's only 1 oxygen in the formula unit, so we actually take the molar mass of oxygen from the periodic table, multiplied by the 1 oxygen in the formula, we get the 15.999 grams of oxygen. Now to get the total mass of all the elements in the compound, all we have to do is sum the total mass of the carbon to the total mass of the hydrogen in the compound to the total mass of the oxygen in the compound. When we do that, we get a total of 46.069 grams of CH3CH2OH per 1 mole of the compound. So we refer to this as the molar mass of the compound. It is the mass in grams of 1 mole of the compound. All right? Now another thing that we can do, which is actually useful down the road in problems that we're going to work, is we might want to deconstruct this in terms of the percent mass of each element that we have in the compound. That's fairly easy to do. Because again, all I need to know is how many grams I've got per formula unit of each element in the compound, and I'm going to divide that by the total mass of 1 mole of the compound. So for example, if I want to calculate the percent mass of carbon, I'm going to take the total grams of carbon in the compound, which I have right here, and I'm going to divide that by the total mass of the compound, which I have right here, again, per mole of the compound. All right? So if I do that, I take my 24.022 grams of carbon that I calculated. I'm going to divide that by the total mass of 1 mole of the compound, multiply by 100, and I find that the compound is 52.114% carbon by mass. I can do the same thing with the hydrogen. If I want to calculate the percent mass of hydrogen in the compound, I'm going to take the total mass of hydrogen that I have in the compound, and I'm going to divide it by the total mass of the compound itself per mole. All right? So I get 6.048 grams of hydrogen divided by the 46.069 grams of compound times 100%. I get that the compound is 13.13% hydrogen by mass. Finally, we have the oxygen. I take the total mass of oxygen in the formula unit of the compound. I divide that by the total mass of the compound. Here we are, 15.999 grams of oxygen divided by the total mass of 1 mole of the compound, multiplied by 100, and I get 34.728% by mass oxygen in the compound. Finally, I can check myself if I want to by just adding those percent masses together, and we know that since we only have carbon, hydrogen, and oxygen in the compound, if I add those percent masses together, I should get back to 100% because that's the total percentage of the various items I have in the compound. Indeed, when I do that to the correct number of sig figs, I get 100.00%. So again, we're going to work with this kind of problem in more detail on Friday, and then we're going to see how we can use percent mass to do other interesting things down the road. All right, we'll see you later.